Now here the question is, prove that this function fx, which is this integral from 2 to e to the power x, 9 cos square 2 ln t minus 25 cos 2 ln t plus 17 dt is always an increasing function of x for all x belongs to R. Now we have to prove that this function is always increasing, then f dash x is always greater than or equal to 0. So we'll find f dash x. Now f dash x will be 9 cos square 2 ln e to the power x, and here will be 25 cos 2 ln e to the power x plus 17 into derivative of upper limit, which is e to the power x, minus, now lower limit is constant, so its derivative will be simply 0. Now this 2 ln ex is nothing but 2x, so we can write f dash x as 9 cos square 2x minus 25 cos 2x plus 17 into e to the power x. Now e to the power x, it is always positive. So here we need to prove that value of this expression is also positive for all values of x. What we'll do is we'll let cos 2x as t, then we can write this function as some gt, which is 9t square minus 25t plus 17, where t belongs to minus 1 to plus 1. So it is quadratic expression, but then its domain is bounded between minus 1 and plus 1. Now if we find g dash t will be 18t minus 25, and if we put it equals to 0, we'll get this number as 25 by 18. Now rightmost is plus and this is minus. Now in this interval between minus 1 and plus 1, we get a negative sign. So that means gt is a decreasing function. And when the function decreases, its maximum value, it occurs at the point where the interval starts, and its minimum value will occur at the point at the end of the interval. So g max, it will occur at minus 1. Now if we put t as minus 1, it will be 9 plus 25 plus 17. So it will be 51, and its minimum value, it will occur at 1. And if we put t as 1, it will be 26 minus 25, and that is 1. So the range of this function gt, it is between 1 and 51, which is always positive. So this expression is also always positive. That means f dash x is always greater than 0 for all x belongs to R. That is, this function fx is always an increasing function for all x belongs to R. Now here the question is, find the value of x greater than 1 for which this function is increasing and decreasing. Now we'll differentiate this function. We'll find f dash x. So we'll put upper limit in place of t and then derivative of upper limit. So it'll be 1 upon x square into log x square minus 1 by 32 into 2x minus, now we'll put lower limit. So it'll be 1 by x log x minus 1 by 32 into derivative of x is 1. Now here x and x will cancel. We'll take 1 by x common. So we'll write f dash x as 1 by x, and then this is 2 log x. So it'll be log x square. So we can write this as log x square minus 1 upon 32 whole square, and then minus log this value. Log m minus n is log m by n. So it'll be 32 by x minus 1. So we can write this f dash x as 1 by x and then log Now this one will be x plus 1 square into x minus 1 square, and this x minus 1 will cancel once, so it will be x minus 1 upon 32. Now first we need to find critical points. Now since in the question it says x is greater than 1, this 1 upon x, it is always positive. So we need to find critical points for this expression. So if we put it equals to 0, we'll get log this value is 0, then x plus 1 square into x minus 1 upon 32, and it is equal to 1. Now we can write this as x plus 1 and then a plus b, a minus b. X square minus 1 equals 32, and it will be x cube plus x square minus x minus 1 equals 32, and this cubic equation will be x cube plus x square minus x minus 33 equals 0. Now if we put x as 3, we'll get this as 27 plus 9 minus 3 minus 33. So it will be 36 minus 36, which is 0. So one of the root of this cubic equation is x equals 3. Now we'll use synthetic division. So it will be 3, and then here the coefficients are 1, 1, minus 1 and minus 33. Now this one will be 0. So this is 1. Then 3 into 1 is 3. It will be 4. 4 into 3 is 12. So it will be 11, and 11 to 3 is 33. Now it will be 0. So we can factorize this as x minus 3 into x square plus 4x plus 11 equals 0. Now for this quadratic expression, value of d is 16 minus 40, which is less than 0. So it means it is always positive and it has no real roots. So the only critical point in this case will be when the value of x is 3. Now what about sign of the rightmost? If we take any value greater than 3, this value in the numerator will be greater than 32. So rightmost is plus and this is minus. That is given that x is greater than 1. Now in the interval 1 and 3, this function is a decreasing function. From 3 to infinite, it is an increasing function. So this function, it decreases in 1, 3, increases in 3 to infinite. Now here the question is, we are given this function fx, which is this integral from x square to x square plus 1 e to the power minus t square dt. Then it says fx increases in which interval. Now if we find f dash x, it will be e to the power minus x square plus 1 whole square into derivative of upper limit, which is 2x, and then minus e to the power minus x to the power 4 into derivative of lower limit, which again is 2x. So we can write this as e to the power minus x to the power 4 plus 1 plus 2x square minus e to the power minus x to the power 4 into 2x. Now what we'll do is we'll take e to the power minus x to the power 4 common. So we'll get e to the power minus x to the power 4 into e to the power minus 1 plus 2x square minus 1 into 2x. Now this e to the power minus x to the power 4, it is always positive. Now what about this one? We can write 1 plus 2x square, it is always greater than or equal to 1, or minus 1 plus 2x square is always less than or equal to minus 1. We can write e to the power minus 1 plus 2x square will be less than e to the power minus 1, which is 1 upon e. Now we subtract 1 from it, e to the power minus 1 plus 2x square minus 1, it is less than or equal to 1 upon e minus 1, and 1 upon e minus 1 is less than 0. So this expression, it is always negative. So everything depends on x. So the critical point here is 0. Now rightmost, this is plus. So it'll be plus minus plus. So it'll be minus, and then before 0, it'll be plus. So this function, it increases in minus infinite to 0, and that's your option D.